Welcome back. This is our sixth video for chapter 3, chemical reactions and equations. And after studying how to balance a chemical equation, today we are going to study the four main types of chemical reactions. As you see in this picture here, we have two reactants A and B. Okay, and in the end, after the reaction, we get only one product AB combined together. So this is a combination reaction where two reactants giving you just one product. So it's also called as synthesis or combination reaction. In the second case, it's just the opposite of the first one now. Now you have just one reactant, and in the end, after the reaction, you get two products. That means one reactant has broken down into two. This type of reaction is called as decomposition reaction. In the third example, you have one compound and one element, and the element displaces this element from the compound and takes its place, and therefore now you get B, which is separated, and A has now combined with C, so you get AC, another compound. And this is known as single displacement because only one element is displaced. In the last reaction, both are compounds, AB and CD. They represent two elements, AB and CD. That is, two compounds are here. In this case, both of them break. A takes the place of C and C takes the place of A. Okay, so ultimately you get AC. A takes the place of AC, and B combines with D, so you get BD. So two compounds giving you two new compounds. Okay, so this is known as double displacement or double decomposition also. Okay, now let's understand the first type, synthesis. Now how do you understand? No need even to look at the reaction. Just by looking at the reactants here and the product. You have two reactants, two or more, and one product means it is combination or synthesis. Carbon combining with oxygen, giving you two elements here, giving you carbon dioxide, one product. Same with sodium and chlorine combining to give you one product, sodium chloride. So this is another example of combination or synthesis. Mg plus O2, magnesium reacts with oxygen, giving you MgO, one product. So this is combination again. Now here you have two different types of compounds giving you one product, calcium hydroxide. Calcium oxide combining with water, giving you calcium hydroxide, just one product. So it's combination or synthesis. Same with ammonia and hydrochloric acid, giving you ammonium chloride, one product. So that means it is definitely a combination reaction. Opposite to that, as I mentioned earlier, in decomposition, one reactant is there breaking down to give you two or more. So calcium carbonate giving you calcium oxide and carbon dioxide. Sugar C12H22O11. Okay, a complex sugar giving you 12 carbons and 11 water molecules. On heating, of course. Then 2H2O2 hydrogen peroxide giving you two hydrogens, two oxygens. Now what you see here in all these cases, you have just one reactant but two or more products. So this is decomposition. Water, electrolysis of water giving you hydrogen and oxygen. Again, a decomposition reaction. Single displacement, as I told you, or just we can also call it as displacement. Single displacement or displacement. One is element, one is compound, one is element, one is compound, one is element, one is compound. The element displaces this element and takes its place. That's as simple as that. Okay, so zinc will displace hydrogen and you get ZnCl2 and hydrogen. Then iron will displace copper, so you get FeSO4 and copper. Then lead will displace copper, so you get PbSO4 and copper. So these are example of single displacement because there is one element and one is a compound. On the other hand, for double displacement, you have both compounds. Okay, and each one breaks into positive negative radical. This positive goes and takes place of barium, and barium comes and takes place of potassium. Silver takes the place of sodium, and sodium takes the place of silver. So in the first case, you got K2SO4 and BaCrO4, barium chromate. The next one is silver. You get silver chloride and you get sodium nitrate, NaNO3. Okay, so this is a double displacement reaction. Now from this you can very easily identify the types of chemical reactions. What do you look out for? You look out for this first. Here there is only one product, so this is definitely a combination reaction. Here there is one reactant and two products, so this is definitely a decomposition reaction. In this case you have two reactants giving you just one product, so this is definitely a combination. Here you have two compounds displacing themselves, so double displacement. One reactant giving you two or more compounds, so this is decomposition. Here you have two compounds giving you two different compounds, so double displacement. Here you have one element and one compound giving you two, and the element has been displaced from here, giving you copper and FeSO4. So this is a single displacement reaction. Okay, now I leave you with completing this from page 46. Match the columns in the following table. The reactants are given here, the products are given here, and you have to choose what type of chemical reaction is it. So you can put an arrow and find out what type of chemical reaction is this. I will complete it in the next video when we go ahead to describe some of the conditions that hasten a chemical reaction. So till then, take care. God bless you.